So hello guys, welcome back. So in this lecture we are going to see how we can optimize our bubble sort algorithm, okay, which we have built in the previous lecture. And if you haven't yet watched the previous lecture, then make sure to watch it because this is a continuation of the previous video only, right? So in the previous video, like we have seen how we can sort a totally unsorted array, right? And in that case this bubble sort was working pretty fine, right? So in that case the complexity of the bubble sort was, um, let me quickly write it down here. It's zoomed enough, I think. Okay, so complexity was big O of n square, right? N square. So that we can say is a worst case scenario. But right now let's say we have a like almost sorted array. Okay, in that case also what will happen, like after sorting the array it will keep on checking for the elements, right? And that is not what we want. And if you are getting confused here, let's see in the visual algo what I am talking about right now. Okay, so let's say I have this nearly sorted array, right? So let's copy the elements of this one. So as you can see we have 2 89 56 3 4 9 11 0 12. So basically these two and this element is unsorted right now. Okay, and right, so now let's quickly create a new array here in this visual algo. Okay, so for that what you have to do, you have to click on this arrow and then create array and then nearly sorted. Here we can pass the data like this. Okay, and then we can hit go. Okay, and I think I have to click bubble sort. Sorry, you're restricted to values 0 to 50. Okay, so we are restricted to values 0 to 50. So let's use 49 and then let's use 50. Okay, so we have to use values from 0 to 50 here, that I was not aware of actually because I'm also trying it for the first time only. Okay, so let's click on the bubble sort. I think we are getting all our numbers here, right? So it will be I think random only. Let's see if, so let's use this one. Okay, so right now we are getting our array here, right? So 250 49 349, right? So let's copy this and let's paste it here as well because I don't want like to use two different values. Okay, 250 49 3 4 9 11. Now it's same as this one. Okay, now if I hit enter, see what will happen. We already have almost sorted data, right? So if I play it, and I have to check like from where I have to play it basically. Okay, now I think I have to click sort, right? Yeah, see right now these two numbers are correct, so nothing will happen. Okay, these two numbers got swapped, right? Now see, just have a close look at this, like how it is going. Okay, so here this number got sorted and then it is going, right? Now see, almost all the numbers are sorted here, right? Only this 0 is there which we have to push here at the beginning, right? So let's wait for it to get pushed here. See, it is still iterating it. Okay, and or let's use like a more sorted data here. Okay, let me quickly move it. So I was using this thing, right? So let's use this at the very end. 0, I'll remove 0 for now. Okay, so let's say 50 and 49. Okay, so now we have, let me just copy this. Okay, so it will be something like this, right? Now we have every element sorted except these two, right? So if they get swapped, then nothing will be there which we have to sort, right? So now let's go with this one. Okay, so it's 2 3 4 9 11 50 49 and 12, right? So now let's see how it works. Okay, so just ignore this one, just just focus on this thing, right? See, right now these two elements got swapped, right? Okay, Now let's see what happens. Okay, so this thing got sorted, and then see, now these two elements got sorted, right? So right now we have all the elements sorted, at least as from the human eyes. Like, we can see like all the elements in the array are sorted, right? But our algorithm doesn't know, like, the array is already sorted. What it will do, it will keep on checking all the elements until it uh, reaches to the first element. Okay, so let me show you what will happen right now. See, right now all the elements are sorted, but it will keep on looping into the array, right? And it will find the last element, and then it will keep on moving, right? Okay, sorry, I did something accidentally. Okay, so that is what we have to restrict it from doing, right? So for that, what we can do, we can simply short circuit it. Like, we have to basically check if the array is sorted, then we have to simply short circuit it. We have to simply stop it from looping again, right? So let me show you here. In this example, I'm using this nearly sorted array. Okay, so the code is same as the previous lecture. So instead of this, I'll be using nearly sorted array right now. Okay, so now let's see how many iterations we are getting here. Okay, so I'll keep it here. See, in this array we have like sort of unsorted array, so it will sort it basically. Okay, so now it will reach to 50, 49, and then it will swap it. Okay, now in the next array also we have some unsorted data, so it will keep on going 49 and 12. Okay, so after reaching this element, it will sort it, right? So right now in this loop we have all the elements sorted. If you can see, we have all the elements sorted in this third loop. This is the third one only, right? Okay, see, 2, 3, 4, 9, 11, 12, 49, 50. Okay, so all the elements are sorted, but it will still loop through the array over and over again until it reaches to the last element. Okay, which is 2, 3, which is this one, right? So once it have reached the last element, then only it will stop looping it, right? So what we have to do, we have to simply do a short circuiting. There is nothing much, right? So for that, we can maintain a flag here somewhere. So let's say it's zoomed, right? So let me zoom it a little bit. Okay, yeah, so we can maintain a flag. Let's say let stop loop, or we can say yeah, stop loop itself. Okay, if you want, you can change the name of the flag. For sake of example only, I'm setting it. Okay, and we can set it to false for now. Okay, and then what we can do, we can simply set it to true at the beginning of the iteration. Okay, and then what will happen, like, we have this flag which we are setting to true when we are starting the loop. Okay, and then as soon as we are getting any swap, right, as soon as it is entering inside of this particular if block, okay, then what will happen, that means we are swapping some elements, right? So in that case, what we will do, we will simply set it to false. Okay, so like this. Now what will happen, as soon as we get any swaps here in this in the any of the looping, okay, so in that case we are setting it to false. Okay, now once this whole loop ends, what we have to do, we simply have to short circuit it. We simply have to check if there is stop loop. Okay, then we simply have to break out of the loop, right? So what will happen, it will iterate through this array. Okay, then it will swap the elements, and then once all the elements are sorted, okay, then it will run one more time, like 2, 3, 4, 9, 11, 12, 49, 50. Okay, and in that case, since the stop loop is true and it will not go inside the if block, then our stop loop will remain true, right? So in that case, what will happen here, it will reach this condition. If the stop loop is true, then we are simply breaking. Okay, so let me add a console log here as well. Okay, so you guys can see clearly what is going on. Loop reached, and then here I'll simply log the flag, or it will be true only. Okay, so let me quickly Okay, we have to format it, right? And it's not happening, I think, for some reason. So let it be like this. Okay, so because we don't want to spend more time on formatting these things, right? So that is fine, right? So this is the code which we have right now. So what I've done is I've done nothing much. I've simply added a flag which will basically check if the array is sorted or not, if it is basically going inside of this if condition or not. If it is not going inside of this if condition, that means our whole array is sorted, right? And then once this nested for loop ends, in the parent for loop we are simply short circuiting it. We are writing a condition like if the stop loop is still true, that means in the nested for loop we didn't find any place where we have to do a swap. So that means that whole array is sorted already. That is why we never swapped anything, right? So basically it is to prevent these iterations, right? So as you can see, in the first iteration we got a swap, second iteration we got a swap, in third iteration we didn't got any swap, right? So from this array onwards, it will stop it from looping, right? As you can see, it already started working. Stop loop reached here true. Okay. So let me stretch it a little bit. I think you guys can't see because of my face here. Okay. So see, right now our pattern count is 3. Pattern count. What is this basically? I don't remember actually right now. So it will be somewhere here, right? Or let it be, right? See, right now it is iterating through this array. The array here we are swapping these elements 50 and like 49, and then in the next and here also I think we are swapping these two elements. Okay, so now here we are swapping 49 and 12, right? So in this loop we are swapping two elements, and in this loop we are swapping two elements. Now we will run a loop once more, just once more, to make sure like there is no other elements left which we have to swap, right? So that is what we are doing in this loop. As you can see, there is no swap in this particular array. Okay, so since there is no swap, so our code will not go inside this if block. Okay, so if it is not going inside this if block, that means our stop loop variable will remain true, right? And if the stop loop variable is true, that means we are going to break it then and there, right? So that means we already have got our array sorted, right? So this is the basically small optimization, but it can impact a lot in case if you have large data set, right? So this was just a small array. Just let's just imagine like you have thousands of elements in the array, right? And it is almost sorted. Then what will happen? Even though it is being sorted already, the your algorithm will keep on looping through the array, and it will keep on trying to find like is there any element which we want to solve? Is there any element or not which we can solve or not? Okay, so we have to prevent it from happening, right? So that is why this short circuiting, or most of the time we used to say this optimization, comes into picture in case of bubble sort. Okay, so yeah, this is how like we can optimize our bubble sort, and in this case like the time complexity will be, so we can call it average case, or like average average case or best case as well. Okay, let's keep it average case scenario. Okay, so here time complexity will be O of n. Even if it is already sorted, then what will happen? We are again going to loop it once. Okay, and then we are going to check if there is any unsorted data, then only we are going to stop the loop, right? So it will, at the end it is going to loop for at least twice if there is already sorted array, right? So that was thing. In that case, like that complexity will be O of 2n, we can say, but we will simplify it down to O of n, right? So this is the solution, and by the way, the code was already there in the description in the previous video. So if you want, you can go check it out. You can get the code from there, and then you can do this optimization in that particular code, right? This is just 2-3 lines of code, as you can see, right? So we have to add a variable here, we have to set it to false, and then we have to set it to true here in at the beginning of the for loop, and then we have to set it to false again in case if we are getting any element which we have to swap. Okay, otherwise we are simply short circuiting it. Okay, that's it. These are just 4 lines of code which you have to add to optimize your bubble sort. Okay, and these are the time complexities of the bubble sort after optimization and before optimization. Okay, so yeah, This is it for this lecture, guys. See you in the next one.